Hi, good morning my dear students and welcome to the world of electronics. Our lesson for today is taken from lesson 3 of module 1 under LX103, which is semiconductor devices. The lesson tackles all about transistor testing and troubleshooting. Our discussion will start with transistor polarities. You have learned class that there are two types of bipolar junction transistors. These are the NPN type and the PNP type. The figures here will show how these two types of transistors are polarized and biased in the circuit. Okay? The figures above show or explain how the transistors are polarized and biased. Remember that there are three layers of transistors. For the NPN type, there are three layers, of course, wherein emitter and collector are negative, whereas base is positive. Emitter and base junction here is forward bias because positive of the power supply is connected to base, whereas negative is connected to the negative side of the emitter. This circuit here show or elaborate further how this junction here of the emitter base is biased. We have here actually the base, which is positive because NPN type of resistor, and the emitter here is negative. The emitter negative is connected to the negative side of the battery actually here. Remember, this ground symbol are connected together. Ground symbol are used to simplify the circuit, of course. So, emitter, which is negative here, is connected to the negative side of the battery. Whereas, positive base is connected to the positive side of the power supply. Okay. Whereas, base collector junction is reverse bias because negative collector is connected to the positive side. Collector is negative here, is connected to the positive side, whereas base positive is connected to the negative side of the power supply here. It's because it is closer to the negative side of the circuit, whereas collector is closer to the positive side. Okay, so let us prove. We have here a circuit based from this diagram. There are three resistors and a transistor. So these capacitors are not included here because we are only measuring the DC voltages. Okay? We have here a power supply wherein the external power supply, wherein the positive side is connected here to this resistor, 3.3 kilo ohms. We have actually here 3.3 kilo ohms. One of the terminals of this resistor is connected to the positive side here. We have here. Then the negative side of the battery is connected to this terminal here. Negative. All these ground symbols are actually connected together and they are connected to the negative side of the battery. So, here. This resistor 680 kilo ohms is connected across base and collector. So we have here 680 kilo ohms with colors blue, gray, yellow. Okay? Okay. So let us now measure the voltage across the base emitter junction. Remember that it is forward bias. We have here. So again, we will set this digital multimeter to voltmeter DC. Okay, we have here DC symbol. So the base is over here. The base is over here. Positive base because NPN type, base is positive, and emitter is here. The voltage here registered on the screen is 0.689. That is actually the biasing voltage for silicon. It is ranging from 0.5 volts to 0.7 volts.
So these biasing voltages are at the active region of this transistor. The transistor should be supplied with this amount of voltages, whether it is 0.5 or 0.7 or somewhere at these ranges of voltages. Because for germanium, it is somewhere at 0.1 to 0.3 volts. But remember that germanium transistors are seldom used today. Seldom used today because of the limited availability of this germanium material. Plus, it is more expensive than silicon. Although, there are advantages of the germanium because of its lower biasing voltage. They are best applicable for demodulator or demodulation. Or demodulator when it is in the circuit. Because that type of diode, germanium diode or germanium transistors can be activated by a small amount of signal. Unlike silicon, which is a little bit higher. Transistors can be activated by this amount of voltage, 0.5 to 0.7. But silicon material is best for power dissipation or temperature dissipation because it has a higher temperature dissipation. No? It can dissipate up to 200 degrees centigrade, whereas germanium is only up to 110 degrees centigrade. So, that is why germanium is seldom used because of its cost, medyo mahal, plus the availability of that material germanium is limited also. Okay. So, base emitter again is always forward bias based from this construction. Okay. Whereas collector and base here, junction is always reverse bias. We have here the base. Base is over here. Okay. Where is the base? The base is over here. Base. Base and emitter is over here. 0.689 volts. The biasing voltage for base emitter junction. Whereas for base collector, it is 4.25 volts. Reverse because it is negative. Actually, we have heard the negative symbol. No? Meaning to say it is opposite polarity. Because when we use analog multimeter, we have heard the base. Base, collector, kickback. The pointer moves at opposite direction. It is not forward. It should be like this. So base here should be negative with respect to collector. The pointer moves forward, meaning to say it is at forward bias. So it is somewhere at 4 point something. We have here 4. Base here. Base is always negative with respect to collector. It is 4.25 volts. That should be the voltage here. 4.25 volts, wherein collector should be positive and negative base. That is always the design of the circuit of the transistor. Base emitter should always be forward bias, whereas base and collector is always at the reverse bias. No? In such a way that there is change of or transfer of resistance to have this amplification. Okay? So, this voltage is actually, okay, let us be sure again here. The negative of this voltmeter is connected to the negative side here, whereas the positive side is connected to base. That is base voltage, 1.4 volts. We call it base voltage, whereas the collector is 5.59 volts and the emitter is 0.72 volts. Those are the electrodes voltages. Those are the bias voltage or the bias voltages provided by the circuit. The resistors here will provide accurate voltages, and those are the voltages being
provided by these resistors being applied with voltage. Okay? The voltages here, the electrode voltages are actually provided by this power supply.
It became 4.25 volts, 0.27 volts because
They are actually designed and provided by the resistances of the resistors. Okay? Then, those are the polarities actually. With PNP type, of course, the same. If it is PNP type, wherein emitter and collector are positive with base negative. Emitter is positive. Base is negative. Again, the amount of the voltages is somewhere at 0.5 to 0.7 volts for silicon. For germanium, if this resistor is made of germanium material, it is somewhere at 0.1 volts to 0.3 volts. Then, the collector is always in reverse bias. Base collector junction here. Positive of the power supply is connected to base. Base from the circuit here. The base which is negative because PNP. Base is negative. It is connected to the if this collector is positive, it is always connected to the negative side. Whereas base is connected to the positive side. Then emitter, which is positive because PNP type, always connected to the ground which is positive. Ground here is positive. We call this one as positive ground. Whereas this one negative ground because the ground is connected to the negative side of the power supply. Whereas here, the ground is connected to the positive side of the power supply. We call it positive ground. Okay? And it is BEE, emitter supply voltage. For the NPN type, it is BCC because it is collector supply voltage. So, those are now the biasing voltages provided by the circuit, actually. Okay, let us now come to the tracing of the current. How the current is circulated to the circuit. Okay? And tracing the current flow, actually we are adopting here the electron flow. We are not using the conventional flow, which is the proton flow. The flow of the current from positive to the negative side. We are adopting here the electron flow, which is negative to the positive side. At first, we have to trace the emitter base current. From this negative side of the battery, it flows here to the emitter, going to the junction of the base emitter junction. Then, it flows here towards the positive side of the circuit. If there is emitter base current, of course, as what we have discussed last time, that the resistance at emitter and collector is getting lower, no? So, the current would be here, emitter, collector junction. There is already emitter, collector current because the resistance here is transferred to lower resistance. That is how the current is circulated in the transistor circuit. Okay. Unlike PNP type, of course, it always starts from the base. The current flows here, negative, it goes like this. It goes to the positive side. Negative of the power supply, the electrons from this negative power supply is attracted by the protons or by the holes of the positive of the power supply because this ground here is positive. So there is base emitter current. The voltage again here is 0.5 to 0.7 volts for silicon. Then, if there is emitter base current, there is also collector emitter current. The resistance with this junction here, emitter collector, is lower. That's why there is an amount of current flowing here. Transistor as amplifier should be supplied with DC voltages. What is the main purpose of supplying voltages to this transistor?
because they are used as amplifiers. The signal at the input, the source signal, actually, for example, the signal from the microphone, there is an amount of AC signal. We call it audio signal voltage. So, that will be fed to the base via coupling capacitor. The capacitor will always couple or will always allow AC signal. If it is DC, it is blocked by that capacitor. So, it is fed to the base. It is amplified by the transistor. The signal is increased from the smaller amount of signal voltage here, somewhere at 0.5 volts. It is now increased to 3 volts. And the output is taken at collector, amplified signal. This is for the common emitter amplifier because there are actually 3 configurations of transistor amplifier. We have the common base, common collector, and common emitter. This is common emitter because the signal is fed to the base and outputted at collector. Emitter is not used as an input or output line. No? Okay. So, common base and common collector will be discussed later on. Okay. That's all for transistor polarities and how these transistor circuits are properly biased. Again and again, biasing is very important for the transistor. Resistances of the resistors here are accurately designed and computed in such a way that the resistors could provide accurate voltages, just like the voltages that we have measured a while ago. Those are the accurate voltages in such a way that the transistor will be put into active region. They can operate normally at full swing without any distortion. The transistor will not be hot. No? It is enough. It is natural for the transistor to become hot because it is working. But it shouldn't be very hot. That is no longer normal. Meaning to say that the resistors are not providing accurate voltages for that. Okay? That's all for this transistor polarities. Okay.